Hello, I'm Dr. Judith Josephs, and this is another episode of History of Success. Starting with this fall, 2023, the University of Massachusetts Lowell will highlight students' paid career-connected experiences during their college career. Success is very important to the University of Mass Lowell, success of students. I would like to welcome today, it's my pleasure to introduce three highly intelligent, interesting guests for today's episode of History of Success. Cheryl Gomez, the Technical Program Manager in the Department of Industry Partnerships and Economic Development. Cheryl's expertise is in fibers, textiles, textile products for protection and advanced functionality, and flexible hybrid electronics. Her education, Bachelor of Science in Clothing, Textile, and Design from Rutgers University. A Master of Science in Textile Science, a minor in Chemical Engineering from Cornell University. Cheryl Gomez, again, a Technical Program Manager at UML for Flexible Hybrid Electronics, Textiles, and Fibers. She has provided technical and design expertise for various military uniforms, various military uniform designs, as well as the shuttle space suit. She is associated with Manufacturing USA Innovation Institutes and Advanced Functional Fabrics of America and the Fabric Discovery Center at the UMass Lowell. She also supports HEROES, harnessing energy opportunities to empower soldiers and advance textiles, mainly for military associations. She is recognized by NASA as an exemplary contributor. We also have with us on Zoom today, we have a PhD candidate, a PhD student in plastics engineering at the Francis College of Engineering, Department of Plastics Engineering. His abstract states that nylon is a commonly used polymer in melt spinning, with uses in apparel and furniture. Chris's studies aim to maximize the flame retardant loading as well as the resulting fiber strengths. The effect of altering the solidification morphology and strengthening the combined system and what will be examined. He is part of a research team developing new materials to safeguard American soldiers and first responders. The research team from the Francis College of Engineering, the teams are developing new materials to help better protect people from exposure to dangerous chemicals and fires, work that they hope one day will save lives. Part of a return to the university's textile roots. The team aims to promote bi-component fibers that can make the military's flame-resistant Army combat uniforms less expensive and more widely available to soldiers. These programs are part of the university's HEROES, again, harnessing emerging research opportunities to empower soldiers initiatives, and this is funded by the United States Army Combat Capabilities Development Command Social Center. Very important research that Chris is involved in. His experience, graduate research teaching and as assistant as part of his job at the UMass Lowell. We are really fortunate to have Chris as part of our program. And I also have with me Edison Niyun. Edison is a graduate, recent graduate, and award winner, Lynn Vocational Technical Institute. His major, IT, Information Technology, and he has been accepted at the University of Massachusetts Lowell in Computer Science. I met Edison and his mother at North Shore Community College, where she was taking the Mass Step program, and Edison was helping her out with that program. We met the North Shore Community professor, and he stated that we would all be working someday for Edison. So we're especially happy to have all three guests on the program today. And we'll start with questions for Cheryl. Cheryl, the first question, what research experience have you participated in as part of your role as the technical program manager?
Judy, first of all, thank you for inviting me for this series. I am truly honored. As a technical program manager, I work with faculty and industry to write proposals to do cool research. That's the simple way to explain it. But I have to look for different opportunities, work within industry, and I also do technical work, especially with my fiber background. I'll work on military uniforms, chem biodefense, flame retardant. So some of the projects that you mentioned, Chris Souza is working on. I'm the technical program manager on those projects. So that's why it's good working with the students and the faculty, because again, we want to promote our students and make sure they are successful in the future. Everything we do is student focused.
Students like Chris, students like Edison, absolutely, student success, very important. And research is definitely one of the most important assets of the University of Mass Lowell. Am I correct?
Yes.
Yes. Could you tell us about the Fabric Discovery Center, which is the nation's first center of this type?
Okay, so the Fabric Discovery Center is one of my proudest achievements. And there was funding back in 2016 for the Fabric Discovery Center, and it's part of Manufacturing USA, and that is a group of 16 innovation institutes, and each institute has a different focus. And we have 3 institutes under one roof in 110 Canal in Lowell, and that's where our Fabric Discovery Center is. So AFOA, Advanced Functional Fabrics of America, we got the funding from the state of, or the Commonwealth of Massachusetts, about $10–11 million to build out the facility and get equipment. And some of that also went to ARM, Advanced Robotics for Manufacturing, where we have our robot center for the nerve center, so New England Robotics, and we have physiological kinesiology and physical therapy. So we even have instrumented treadmills, and we also have part of flexible hybrid electronics, FHE, and that is part of Next Flex. I have to say it slow because otherwise we say Netflix or whatever. And so when you think about flexible hybrid electronics, think about a circuit board. Typically you have a hard circuit board. Well, flexible hybrid electronics makes it flexible. and more conformal to a body. If you want to have electronics, you could have a wearable antenna or physiological monitoring. And so you need to put that all around your body and be able to monitor the signals.
Wow. I see hands-on, applied, practical research being done at the University of Mass, Lowell. Am I correct, Cheryl?
Yes, it's hands-on, and in that building we have an ecosystem where we can actually extrude fibers, twist yarns, weave fabrics, knit fabrics, test them, and we have a prototyping facility, so now we can fabricate garments or products and evaluate their performance, like a physiological monitoring shirt. We have the instrumented treadmill that we can evaluate it on. So everything in that building, we can go from start to finish.
Wow. Explain your experiences with fibers and textiles.
Well, when I was young, my mom sewed. So of course, I followed mom and I loved to sew. But what can you do with a degree like that? So undergrad, I went for clothing, textiles, and design. And when I took my first textile class, I had that aha moment. It's like, oh my goodness, I can take some of my science knowledge and put that together with fabrics and work to help people. And firefighters, military, and then of course the shuttle spacesuit. My first job at a grad school was for ILC Dover in Delaware, and I worked on the shuttle spacesuit. A lot of it was working with the gloves, and you need to have dexterity. So think about a spacesuit. You're in the middle of a balloon. So when that last glove or helmet clicks on, it all expands around you. And so you need to be able to grab things, and also it's all safety, and you need to protect people. So that's the ultimate space vehicle, a spacesuit out in the vacuum of space.
What is your role at UMass Lowell regarding helping to elevate the research status of the university?
Well, UMass Lowell is a R2 or Research 2 level university. And a university like UMass Amherst is an R1. So we are looking to rise up to the challenge and become an R1 university. And a lot of that is part of expenditures. So working on the proposals, getting research in. When you get research in, you get more students, and you need more doctoral students like Chris, and then you also get more faculty. So it's a domino effect. So by increasing the research at the university, it just leads to bigger and better things.
Okay. What characteristics do you have that make you a leader?
I think my main characteristic is integrity. And when you think about it, that's what you have. And like they say, if you see something, say something. That's real. And stand up for what you believe in. And people will respect you and follow you. And in the leadership role, when after grad school, I'm like, you know, a lot of people gave to me their time and energy, and I wanted to give back. So I would go back to my high school and give presentations on some of the work that I did, that brought pieces of the shuttle spacesuit so they could understand it. I would go to Cornell and give seminars on new evaluation techniques or materials that I was working on that they could work on in the future. And I'm hoping that some of the audience will also see that, and they'll give back as they pay it forward. And so I encourage people to do that, because it's really important, because then they're the leaders of the future.
I know you have many accomplishments. What are some of those accomplishments that you are most proud of?
The most recent one, of course, is the Fabric Discovery Center. It was a team led by Chancellor Chen, and we had a number of people, but writing the proposal for that, and then figuring out what's going to go in this 30,000 square foot part of the building, two and a half floors. And so we brought in members of the community in industry that dealt with military, first responders, and the companies like Raytheon and Polar Tech and New Balance. And it's like, what do you need? And so we talked to them about the equipment, the prototyping, and then we designed the facility around that equipment and worked with the engineers and got it built. And that was a huge bonus, and like a baby. You nurtured it from the beginning to the end.
Again,
yeah.
Hands-on, applied, practical research going on at the UMass Lowell. What are some of the challenges that you see research and technology innovation face today?
Some of it is funding for work and trying to get the funding for the research. And so we're looking at the different databases on where the proposals are coming from, or going to companies looking for what they need. What keeps you up at night? What help do you need? And then work with the students and faculty on those projects.
Okay. You mentioned some of your industry partners. I understand, some 200 industry partners in connection with the UMass Lowell in research. Who are some? Can you mention some additional out of 200 industry partners that you have at UMass Lowell?
And some of those partners are sponsors, DCU, but some of them also do research. And some, like Raytheon, we are co-located in the Saab ETIC building with Raytheon in a Raytheon UMass Lowell Institute. And they provided funding, and they actually have some of their engineers and scientists sit side by side by our faculty and students and provide funding for research in printed electronics. And most people think, okay, I'm just going to print on a fabric or a film or something. But they do stuff conformal, so they do it in 3D. So it's not just the normal things that people think of. You have to think outside the box.
Okay. Chris, questions for you. I gave some of your background, but tell us in your own words your background.
Yeah, so I grew up in Billerica, Massachusetts, right outside of Lowell. And a lot of our students end up going to UML because it's local. It's also a state university, and thus a lot cheaper than a lot of our other universities. We here in Massachusetts, specifically Middlesex County, Merrimack Valley, we are spoiled for choice in university and how many there are to apply to. But in terms of costs for payoff, UML is really a great place to go. I, chose UML because of the cost. I could commute from home, living, with my parents and all. But it still gave a lot of different options. I did not choose to necessarily go into plastics engineering when I was applying, but quickly fell into it my first semester at the university. because there were so many different options to choose from, just within the Francis College of Engineering, but also with our other colleges at the university. I wound up choosing plastics based off a PowerPoint that was given by our former department head that showed that it was a good combination of, the physics side of things and the chemistry side, and I fell in love with processing from there.
Okay, you have completed your bachelor's degree, of course, at UML as well. So you've been there a while, I think 3 years in the PhD program. What have you liked best about UML?
Well, specifically, I love the department. I started working for my advisor, Professor Stephen Johnson, in undergrad, and he's, a great guy to work for. It's cliche to say like, oh, well, we love the community, but that really is the case. I've had the pleasure to work with a lot of great fellow students over the years, many of whom I've now, lifelong friends. Go meet with them every 6 months in the cabin at least, outside of generally meeting up outside of work. But we also have great equipment to work with. I do a lot of my work on a bicomponent fiber extrusion line, which, while very complex, is very fun to work with.
Okay, opportunities. What opportunities that have been available to you since you've started at UML?
So for research opportunities, Cheryl has talked a lot about the Fabric Discovery Center. That's just one of the labs that we get to work with. I've been able to work with a micro-compounder down there that allows us to do monocomponent fibers and small batch blending, plenty of tensile testing equipment. On North Campus, we have great microscopes, SEM. We just got X-ray systems up, which I'll probably use for analyzing crystallinity of fibers. Again, our high bay system in the ETIC Center, which Cheryl talked about, that's where the fiber extrusion line is. In terms of outside of research opportunities, I've gotten to teach seminars over the summer and a few times during the semester to industry professionals with plastics processing, mainly in injection molding and part design, which has been great because I've made a lot of connections through that. Seeing what other people care about in terms of plastics outside of my own specific research focus, and tried to help them out, see where their blind spots are with plastics processing.
Are you commuting or living on campus?
Oh, I'm commuting. That's what's good about UML in terms of my location. I had mentioned before, all of undergrad, I took the LRTA bus system to campus, and then now in grad school, I've had the opportunity to buy a car and drive in, but just because the LRTA only runs for a certain amount of time. But I commute.
What surprised you the most about college life at UML?
So that's a good question. I've come from a family with both parents were college educated, so I was able to anticipate a lot going in. I'd say what surprised me most would honestly have to be not necessarily the workload, but the way in which that I do work. I figured, coming out of high school into undergraduate, that it would be, kind of a constant drone of work. But what it really turned out to be was, you get these high periods of productivity followed by periods of low productivity. And then in grad school, that becomes what honestly surprised me was after like the first year, how I was able to treat it like a 9 to 5. And that is really advisor dependent. My advisor is great in terms of that regard with work-life balance. Not everyone has that opportunity.
What accomplishments are you proudest of achieving thus far in your college life?
So two things. One was a class that I took was advanced mold design, where we were able to go through the process of actually designing a whole injection mold. In my case, we were designing a mold for zippers. Now, we didn't get to actually manufacture that part, but because molds can cost hundreds of thousands of dollars, so obviously it's going to remain theoretical. But with a lot of simulation work, you can validate it to the point where, yeah, this will work, and go through that whole process. And that was a lot of work to do. You go through all the steps that someone in industry would to design a mold, up minus milling it and qualifying it. But that was very rewarding to go through that whole process. But also in terms of the research so far, we have gotten two materials which are completely recalcitrant. The flame retardant and the nylon that you have mentioned in the introduction. Those two materials react with each other, and my dissertation is focused on looking at what that reaction is. But suffice to say, when those two materials touch each other, while we're trying to process them at elevated temperatures, they form a gel, char, stuff that does not stretch into a fiber and will actually end up clogging our whole system up. But we've managed to use co-extrusion and blending to inhibit that reaction to the point where it's stable just long enough for us to get it into a continuous process. But it's took us several years of dealing with, that material clogging up in our extruder system, breaking our fibers, just a simple shutdown. If the power goes out for a minute, it's done. You have to spend a good 16 hours resetting the whole system, but we finally got it to work. And now the dissertation work that I'm doing is focused on trying to improve it, get slightly better performance out of it.
If you were to state maybe one of the most exciting, interesting parts of your research experience, what would it be?
I would have to say working with our, I mentioned that we're blending our materials. One of the most interesting things that we found was that, so we're blending our flame retardant with a polyester, and that's flowing in the core of our nylon. In co-extrusion. And we had anticipated that what was helping us actually achieve a stable process was that it was, trying to think of how to explain this, that it was leading to different viscosity differences in our dye. In plastics processing, we are very concerned with the viscosity, the resistance to flow that our materials have. When you're flowing more than one different type of polymer together, that becomes very important because it can lead to a lot of different instabilities, such as stuff called encapsulation, waveform instabilities, but that's getting into the weeds. But what we found was that by changing the ratio of our flame retardant to our polyester, we were changing the morphology. Are we getting, and think of, your Italian dressing, right? If you shake it up, you get little droplets of water and oil in it. Same idea with the polymers, and that morphology was changing based on the content ratio of flame retardant to polyester, but also based on our processing time, whereby keeping that material hot for a very long time, we could stabilize the system by changing that morphology, gaining something where instead of having a majority of flame retardant, we had a majority of polyester and chemically connected flame retardant. And that inhibited it from reacting with our nylon. That's the theory anyways. I'm still working on proving this. And that's what allows us to be stable. So that has implications in how much flame retardant that we can load and potentially make the nylon fibers more resistant to flame catching on it, but also preventing its spread and thus a more effective uniform down the line.
Important to our military, important to first responders, very important area of research.
Yes.
I highlighted at the opening of this show paid internships. Have you had any, or do you have any lined up for your future?
So I've had one that was at a local manufacturing plant. A lot of our students have great paid internships through our co-op program. Mine was all right. It was less engineering than I expected. It was more working on the factory floor, but I think I got a lot out of that in terms of being able to work with people who are actually manufacturing, see what their struggles are, see what they care about, and what actually happens on a manufacturing floor when you're in full continuous production. It's actually a little bit of issue in terms of hiring undergraduate help. When we're trying to get help for our graduate students with undergrad students, they have these great co-ops. And so it's very hard to convince them to stay on campus and help us over the summer.
What would you like to see happen to you after graduation? These thoughts must be in your mind. You're getting a little bit closer.
Absolutely. Hopefully the next few months here. So my hope is to get a job in New England, doing a research with a private industry, be a full-time R&D engineer, ideally Massachusetts, but, New Hampshire, Vermont, Connecticut, Rhode Island, all those are great options too. Hopefully still looking at extrusion and blends, but I'm also open to other opportunities. So if anyone's watching.
The big question today is whether or not a college education such as yours offers a strong career future. Many students are thinking about just taking a job and maybe they can be trained in their company. Why do you think it's so important that you followed the road that you did?
So let me preface this with, not going to college is still a perfectly valid choice. Going to college is not equivalent to intelligence. It is another method of training. And what going to college does is it gives you a more well-rounded knowledge. When your company is training you, if you go down that route, they're training you to do the job that they want. What a college education is going to do is give you a broader idea of what's important and give you marketability. When a company trains you, they, like I just said, they train you for what they want, not for what's going to allow you to have a broader career prospects. They don't want you to leave the company. By getting a college education, you're making yourself marketable to a whole host of companies, giving yourself more options down the road. And you know what? Yeah, I'm doing a PhD. I do still care about knowledge for knowledge's sake. You're going to get information that isn't necessarily instantly marketable, but gives you the broader context to make you more effective in future work.
Your experience at the UML, you mentioned one business contact that you had out as a paid intern. How about other business contacts, especially in the research that you've been doing?
So, most of my work is contracted through the U.S. Natick Army Labs, but I've had the opportunity to help out with other companies, coming in to do small amounts of lab work. Some fiber companies out of California working with polyester. We have a lot of companies which sponsor our labs, like Danisco, so that help our research. And I mentioned before that, I TA a lot of seminars over the summer. We have companies from all over the place, some automotive, biomedical, resin manufacturers, all sorts that come in, and we train them in how to deal specifically with plastics, where they might have more general experience and limited knowledge of material science.
Okay, thank you very much, Chris. And we're going on to a recent high school graduate, Edison Nguyen. Edison Nguyen is a Lynn Vocational Technical Institute recent graduate, majoring in IT and accepted at UML in the field of computer science. Why did you choose UMass Lowell for your college?
Thank you for this opportunity for bringing me here. The reason why I chose UMass Lowell as my college is the main reason is it is in-state and affordable. It's in-state and affordable. That is an excellent research school.
Primary reason then, it's located in Massachusetts and it's affordable.
Yes.
Okay, very important points. Do you believe that your career will be enhanced by your choice in computer science as your major?
Yes, I do. I do firmly believe that studying computer science will help my career prosper. From our world using more technology day by day, and it helps in many different fields.
It's all around us. Computer science, everything we do in everyday life now, it's such a growing field. What in particular do you like about it?
What I like about computer science is just like the problem-solving aspect of it. It's like finding out what's wrong with code or what's wrong with this device to open up and try to fix it.
And you can fix it.
Yes.
Yes, no matter what's wrong. A handy person to have on board in any company. Will you commute or live there?
I will be living at UMass Lowell since I live in Lynn, and I do not want to drive 40 minutes in the winter.
Very heavy traffic. One day I went there, and it's definitely heavy traffic, and I think living from Lynn, it's definitely a good choice to live there. But still, it's possible from this area to commute as well. Do you know anyone who has do you know from around here, anyone who has attended the UML?
Yes, I have a couple of friends that are currently attending.
So you will have friends there.
Yep.
When you are living there. That's great. The background that you had in high school, do you think that's it's going to help you? Your IT background will help you with your future career as a college student at UML?
Yes, I do think so, because people have bought devices to fix it in my at my shop. And I have repaired phones, laptops, and game consoles.
So you've had a lot of applied hands-on experience in the computer science field already?
Yes.
Yes. Okay. What is your goal in attending UML? What do you hope to achieve?
I currently don't have any goal right now, but I have a goal for graduating college in general, and that's either achieving a master's or doctoral degree.
Master's, listen to that, Chris. Master's or doctoral degree. What do you think in computer science? Chris? Oh, can you hear me?
Yeah, so in computer science, I can't really speak to that, but I think in general, by getting a PhD or a master's degree, you are putting yourself at a slightly higher level in terms of salary negotiations, so great for you. But also, if you just like school, you won't do a graduate degree unless you enjoy being in school. But getting that PhD, if you choose PhD, for instance, it's very interesting because you get to choose a specific research goal or niche within your field that you love, and you can specialize in it, explore it, grapple with it, and then when you go forth out of the university, you're setting yourself up for staying in academia, becoming a professor. That's what I originally wanted to do, but if you keep on and say, hey, I've had enough of academia, I want to go into private industry, you're now the expert in one small area of human knowledge, but you know it better than anyone else other than maybe your committee. And that's going to set you up for a lot of success.
Okay. Edison, many students today are going directly to work after high school, but you choose to go on to further education. Why? What is the most important reason for your going on?
The reason why I went to college instead of going to work is to try to learn new subjects that can only probably be obtained by college,
higher level courses.
Yes, higher level courses, and trying maybe a new major if chemical engineering.
Like chemical engineering. Wow. Okay. Again, the main reason for choosing to go into college, particularly UML, the main reason for you is?
The research.
I'm sorry?
The research.
Research. The research at UML is amazing, so I think you've made a good choice. How does your family feel about your choice of school? I know we have a picture that I sent to Pedro regarding the award ceremony. Your mom was there, and I'm there, and you're there in that picture. And and there is the picture with your mom in it. Okay, so how does your mom feel and your family feel about you going on to UML?
They feel proud. They feel proud, but also very sad since I'm going to be living away for a while.
Yes, yes. Okay, back to Cheryl. Cheryl, there was an article that came out about the Fabric Discovery Center aids companies with personal protective testing and design equipment, PPE. We all know that during our pandemic, the PPEs were very scarce. They were extremely scarce. And that state and federal grants support testing and emergency manufacturing efforts. Well, we know that that is probably not our last pandemic. So, how does the Fabric Discovery Center, of which you helped to start, help industry make better and faster personal protective equipment? Very important in the time that we are living in.
Well, during the pandemic, the Commonwealth of Massachusetts and some other Massachusetts areas, the M2I2 that helps provide funding for the capital equipment that we've received, and they formed an initiative trying to help the manufacturers pivot from whatever they're manufacturing to pivot to making masks or medical gowns and things like that. So we received money for equipment, so we had a filtration efficiency tester, and we also had synthetic blood tester for masks and some items for water penetration, so it would be also similar for medical gowns. And companies would send us masks and we would evaluate them. Now, one wouldn't think that the Ford Motor Company would be making medical masks and the N95, but they pivoted some of their manufacturing and did that. And so we evaluated their masks, and they did fantastic. And they were able to get them through NIOSH testing for people to use them. And so we did that for numerous companies as well as the Commonwealth, because a lot of people saying, oh, well, how do we know these masks really protect? And so we're spending millions of dollars on masks. So we could say, yes, this has 95% filtration efficiency. And it's like, oh, but this one here only has 60%. So that's not up to the specifications, correct.
Wow, okay. Then the Fabric Discovery Center played a very important role during the pandemic in checking out the equipment, especially the personal protection equipment that we were using. And so very special congratulations to that center. What type of research takes place at the Fabric Discovery Center? Smart fabric partnerships with industry and academia, that advanced functional fabrics of American government partnerships with industry and academia. Very, very important area.
It is. And we've worked with AFOA, Advanced Functional Fabrics of America, and we've worked on different electrical e-textiles, e-fabrics, and connectors. And so you're trying to even put optical fibers in fabric. And so we've used some of those to gauge changes of bridge stability, or you could do it in tunnels. So you put an optical fiber in a fabric and then attach it, and then you basically send a pulse optical thing and looking for a discontinuity in the fiber length. And if it doesn't make it all the other way, then you know there's a problem. Or you could measure temperature of the temperature changes and look for cracks in the foundation and things like that. But the Fabric Discovery Center is also, the funding we bring in is through our core research facilities. And so the equipment that we have, the faculty and students can use it, like Chris's project was using some of our micro compounders and tensile testing. So we train them on the equipment, and then they can sign up for it and reserve it and run the equipment themselves. So you have different price points for whether you're doing it yourself or you're training someone, or we do it as service. Like some of the mask testing with the FOA, they've got additional funding over the years for coming up with different mask materials and things like that. So it helps us pay the bills by using the core research facility. And the CRF also offers small businesses in the Commonwealth for a voucher. So if you're a small business and you need some extra help, you can apply for some of the money, and depending on how many employees, you can get up to 75% off of the cost of using the equipment.
Okay. What are testing techniques that are used to test measuring of water resistance, repellence of fabrics, and water pressure required to penetrate gowns and masks? Certainly blood in many instances would have gotten over masks and gowns. What are your techniques to determine whether these masks are going to work or not, whether these gowns are useful or not?
Especially for the gowns, we have a hydrostatic pressure test. So you could put the fabric over basically a water, and you clamp it down, and you increase the pressure, and you're looking at stopping it when it hits 3 different drops of water coming through. So if it's like 20 pounds, it might be for a lower level material, or if it's over 50, then you're looking at a very high level medical gown material. And then you want to do a seam. So when you're making these garments, you're going to test an underarm, basically an armpit down further, and a shoulder seam. So it's not just one area, you're testing the fabric as well as the seams.
Wow. An important partner, Department of Defense, United States military, very important. And so could you tell us more about research that occurs at UML that affects the Department of Defense, which is important to all of us?
Especially for the HEROES projects. We work with Soldier Center in Natick, and we don't just on the projects work on just for military. We make sure there's a commercial product or idea as well, because you don't want to just have it for one set of users. And so our partnership with the Army there is invaluable. They also have their scientists co-locate at UMass Lowell in one of the buildings, and so they're working side by side with students and faculty again, which is a huge way to advance science and technology.
Community activities. You told me that you're leaving right after this show for a community activity or a connection with a business partner. What other community activities are you involved in to keep this tremendous connection to more than 200 business and industry partners?
Well, one of the things I do is volunteer and work with student science projects, especially the STEM and through the Commonwealth. And now, of course, a lot of things are virtual, but we would go to students and talk to them during workshops and give them advice on some of the projects they're working on. They would be given a choice of projects to work in, and a lot of that isn't necessarily fibers and textiles, but the thought processes of looking at how to research something is all the same. So it's good working with them, and again, you're mentoring, and hopefully those students will help those in the future.
Okay. Chris, I wonder, community activities for yourself. I understand you are a teacher or a tutor for some of the students at UML. Any community activities that you might like to share with us?
Yeah. So our department hosts a science fair every year for kids. It's been run by Professor Barry for several years now, and now Professor Kokel has taken over for a lot of it. But every year in April or May, a lot of kids from the area are able to come into UML to our Tsongas Center and present their science fair projects that they do for their middle schools. And people from our department, students, faculty, former recent graduates will come in, judge, and it's great. Cheryl mentioned that a lot of stuff is online, but we've came back in person this year, and it's great because you can actually give feedback to the students in real time, and you can ask them questions and see, how much do they know, how much, did their parents help them, which isn't bad, but did they understand the help that they were getting? And what they contribute, and that's always very fun and rewarding. You get to see which students have better scientific methods than you do, and get ideas from them actually.
How about Edison? I met you at North Shore Community College, and you were helping out in the Mass STEP program. That certainly is a community activity. You were helping your own family. Any other community activities? Certainly you're fixing, when people bring things in the school, you're also doing hands-on fixing of equipment. Anything else you'd like to share with us?
I don't have anything to share at the moment, but
Okay, but those are two. Anything you'd like to tell us about what you did at North Shore Community College to help out? What did you actually do?
I just talked with the instructor a little bit and just trying to see if I could find anything to help him with, any programs to use or any simulations to help with the courses.
And they certainly knew you, so I think it was a good thing to do. Okay, the future for Cheryl. What do you see in your future?
Well, one of the things we're doing at 110 Canal and the Fabric Discovery Center is revamping our prototyping area and our makerspace. So that's the immediate future. We're working on getting new equipment and being able to reach out to entrepreneurs and small businesses to be able to use the facilities for prototyping, more for technical areas and not really fashion, even though fashion is nice and I love color, so I love colors to pop. And but when you're working, my UMass Lowell blue shirt. When you're working with prototypes, one of the Heroes projects was a cooling vest. So you actually had sewing or putting tubes through fabric or sandwiching it between and helping somebody, a military uniform, race car driver, firefighters, being cooler in what they do. So they changed the material properties to do that.
Okay. What do you see in your future? What does your future look like, Cheryl?
Again, we're just trying to get more funding for the university to be able to help students and faculty, and it's great when Chris has the research assistantship or the teaching assistantship, and a lot of the grad students are doing that. So it's important for that. And I'll be doing some more technical work on projects as well as working on proposals.
Cheryl, quickly, one sentence advice to students, especially if they're thinking of going to the University of Massachusetts at Lowell.
Do it. I think, and I liked Chris's response earlier that sometimes going to college isn't the right path, but for those that do, get the experience, get as much as you can, take as many classes and learn lots of different things. It really helps build your life experiences and all. I lived at home. I commuted undergrad and grad school. I lived on campus, so it was finally some time to do that. But
I would like to thank all three of my guests, my amazing guests today. Cheryl Gomez, Technical Program Manager in the Department of Industry, Partnerships, and Economic Development, University of Massachusetts, Lowell. Christopher Souza, a student in plastic engineering at the Francis College of Engineering, Department of Plastics Engineering, a PhD candidate, hopefully soon to finish, says Chris to us. We are very pleased to have him. And then finally, Edison Nguyen. Edison, a graduate and award winner from Lynn Vocational Technical Institute, a major in IT, and accepted at the University of Mass, Lowell in computer science.